your favorite part of human-powered vehicles?
The relationships, man.
Tell me more about that. You're talking like individual relationships or businesses?
Individual relationships. Other engineers, upperclassmen. It was a big deal whenever I was an underclassman, and now it's pretty cool getting to know the underclassmen that way, showing them how to do stuff in the shop and in CAD.
So you come up with the designs and then you build them?
Yeah.
And is there a competition this year, or is
There is.
It is?
Yeah, well, it's next spring.
Next spring.
Yeah, so we've got a few more months till about April. Each team needs to sort of start from scratch in order to actually qualify for the design competitions. So you're not allowed to reuse any designs from previous years. You need to completely start over, starting in the summer, and then go through the complete design process of building a bike, testing it, and refining it. And then there's also a large portion of the competition is also like innovation.
So what are some of the requirements for the bikes?
So it's kind of strange. If you look at any of these, you won't see it. But basically the main requirements, you can make anything. You can make a long wheelbase like that one, where the front wheel is like way out in front of you, or you can make short wheelbase ones where the front wheel is like kind of underneath you a little more. You can make trikes like these two. There's no limit. You can do four-wheel bikes, but basically the main requirement is you have to have a roll cage, which none of these actually do, but that would basically involve a network of tubes that comes out and over top of your head and around your shoulders to kind of protect you at all points. And then you need at least a 3-point harness. We're doing a 4-point harness, so that in the case of complete inversion, the rider is not touching the ground at any point.
So speed, safety, and durability?
Yeah, exactly. Yeah.
Oh, man. Jake, get off your phone.
What is one of the biggest challenges that you guys have to overcome when building these bikes?
So for myself, my role kind of this year is the frame sub-team. So my job is creating the frame in the software, and then going through all the scenarios of loading it might encounter to make sure it's not actually going to do any yielding or failing. So no bending or no braking.
What kind of software do you guys use?
So we're using Creo Parametric, which is just a CAD software, and then in that we've got all of our simulation tools. Whenever you start off in the club as like a freshman, you rely on the upperclassmen to kind of give you pointers and things to do. And as you move into those roles, you've learned some over your years of doing it, but then you're also learning a whole lot from Dr. Archibald in the nitty-gritty, exactly how to conduct all of the simulations and analyses that you need to. It's really cool getting to see the whole engineering process in a year. So like your classes, you start out as a freshman, you're kind of like just doing a lot of math and stuff. And then like as you get to being an upperclassman, you do a lot more engineering courses. And it feels a lot more like real engineering, but you don't really get that until you actually have to solve a problem that extends over the course of months, even years. And so this is very much so that it's really cool to see the whole process start to finish and to have a big say in that. Also, I really, really love just the relationships that it builds with the upperclassmen and with the professors. It's great. I never would have gotten so close to Dr. Archibald if it wasn't for something like this. So,
Thanks for showing me the bikes, Tim.
yeah, no problem.
Could you please wave? That was weird.